a mysterious Martian mineral that has perplexed scientists since its discovery 7 years ago may have been spaced out during an unusual volcanic eruption. Researchers have revealed the mineral, which is normally only found on Earth, was likely formed on the red planet more than 3 billion years ago. NASA Curiosity rover discovered the mineral inside a rock at the heart of the 96-mile-wide, 154-kilometer Gale crater. The rover drilled a small hole into the rock and extracted a silver-colored dust sample. Curiosity on board X-ray diffraction laboratory analyzed the dust and detected tridymite, a rare type of quartz made entirely of silicon dioxide or silica that is formed by certain type of volcanic activity. The unusual find was totally unexpected. The discovery of tridymite in Gale crater is one of the most surprising observations that the Curiosity rover has made in 10 years of exploring Mars. The discovery of tridymite stunned researchers for two main reasons. First, Mars volcanic activity was previously thought be unsuitable for producing silica-rich mineral like tridymite. Second, scientists believe Gale crater was an ancient lake and it has no visible volcanoes nearby, which left scientists scratching their head as they tried to figure out how the mineral ended up at the bottom of the lake. Researchers have come up with an explanation that may finally unravel the mystery. The researchers suspect that the explosive eruption of an unknown volcano launched tridymite-rich ash into the Martian sky, which then fell into the ancient lake at Gale crater. When the ash fell into the water, it would have been broken down into its individual parts by a combination of physical and chemical process. The researchers think this is why the sample of tridymite is so pure and not contaminated with ash. If the ash were directly deposited at the location we found it without water, we would expect thick layer of ash. A similar scenario has been observed on Earth at just one location at Lake Ticomolco in Mexico, where tridymite was found within the volcanic rocks brought up from the bottom of the lake. If tridymite-rich ash did fell into Gale crater when it was still a lake, then the eruption likely happened between 3 billion and 3.5 billion years ago, which is when researchers suspect the crater was full of water. The explosive eruption must have happened in that time frame. However, recent studies have shown it is possible that Gale crater was still a lake as recently as 1 billion years ago. The researchers remain unsure about where the volcano that birthed the tridymite sample is located on the red planet. It could have been from a small eruption nearby or from a massive explosion much further. It is hard to locate past volcanoes on Mars because it is challenging to distinguish between the impact craters and volcanic that have been eroded over billions of years. The researchers also had to explain how tridymite formed on Mars, where conditions are thought to be very different from Earth. Normally, tridymite forms in extremely high temperature and silica-rich volcanic environment, which are common on Earth. However, previous evidence from Mars suggests that the volcanic eruption on the red planet were basaltic, meaning they had a much reduced silica content. This is because Mars doesn't have tectonic plate, which are the main source of Earth's silica-rich eruption. Further analysis of the tridymite found on Mars revealed that it was slightly different to the tridymite that forms in volcanoes on Earth. This suggests that the Martian version was formed under slightly different conditions. The researchers proposed that the tridymite found in Gale crater was formed over a prolonged period within a magma chamber underneath the unknown volcano. The temperature within the chamber would likely have been slightly slower than the condition in tridymite forming a volcano on Earth, but the team believes this might have enabled the mineral to slowly form and additional silica became available. Similar mineral formation pathways have been observed on Earth, and the scenario represents the straightforward evolution of other volcanic rocks found in the crater. Although the proposed formation of tridymite on Mars require less silica than on Earth, the researchers point out that the volcano that birthed the sample found in Gale crater likely had a higher silica content than past evidence. This work suggests that Mars may have more complex, intriguing volcanic history than we would have imagined before Curiosity. Further discovery from Curiosity and its successor Perseverance rover, as well as Martian rocks brought back to Earth by NASA proposed Mars sample return mission, could help shed more light on Mars.